Okay, we're ready to start with Wednesday's lesson. So this is Algebra 1 for Wednesday, the 20th of August. And we're going to start with fractions again, but this time we're going to be multiplying fractions. And multiplying is much easier than adding and subtracting. The rule for multiplying is you multiply the numerator straight across, you multiply the denominator straight across. So in our first example up here, if I multiply, now here I'm using an X for multiplication, but I'm going to rewrite that so that you see what I'm doing. I'm doing 2 times 5 all over 7 times 11, and here I'm using the dot to indicate multiplication. I multiply the numerators. 2 times 5 is 10. I multiply the denominators. 7 times 11 is 77, and there is my final answer. It will not reduce, but that's a good thought to see if it would reduce. In the next example, we're going to pull out a little rule that we use a lot. It's very, very simple. Let's say you cut a pie into 6 pieces and you ate all 6 pieces. Let's say you ate 6/6 of the pie. You ate the whole thing. Any number over itself represents one whole thing. It means I have all the pieces. I have 6/6 here, or I have 3/3, or I have 2/2. I have all the pieces. So any number over itself is equal to 1. Well, what happens when we multiply anything by 1? If I multiply 1 times 7, I get 7. 1 times 1,000, I get 1,000. 1 times Joe Smiley, whoops, you can't see Joe Smiley, I'll put him down here, is equal to Joe Smiley. 1 times anything is itself. So we're going to use that little rule that any number over itself is 1, and that 1 times anything is itself. In other words, when multiplying, 1 becomes irrelevant. That's what we're going to talk about now. We're going to rewrite this multiplication, 3/5 times 4/3, as 3 times 4 over 5 times 3, because the rule in multiplying fractions is you multiply the numerator, you multiply the denominator. 3 times 4, well, you can multiply it straight across and then reduce, or we can use the little rule we were just talking about. Anything over itself is 1. This is cancellation. 3 over 3 is 1, so I'm in essence factoring it out. Now all I have left in the numerator is 4, and all I have left in the denominator is 5. Now we could have multiplied this straight across and gotten 12 over 15 and then reduced it from there. It's just more work. Okay? At this point, I hope you don't have to do all those extra steps. If you do for right now, do the steps. If not, if you can see to cancel the 3's in this stage of the game, then you get to the lowest term answer more quickly. Here's a number, 4 times 2/7. Here's another little rule about fractions. Anything over 1 is itself. So 4 can be rewritten as 4 over 1. So we would write this as 4 over 1. You can put that into any number, put it over 1, and it doesn't change the number. Now the rules apply for multiplying fractions. Multiply the numerator, 4 times 2. Multiply the denominators, 1 times 7. I'm going to look to see if anything cancels. In this case, there is nothing over itself or anything that would reduce to that, so we're going to multiply straight across. 4 times 2 is 8. 1 times 7 is 7. Yes, we end up with an improper fraction. In my class, that's absolutely fine. I'm not sure what your answer key would show here, so let's show you the alternate form of the answer. The alternate form of the answer would be 1 whole thing with 1/7 left over. So you have that answer, or you have that answer. Either one is accurate, and either one is fine for me. Usually form for answers, you go with your teacher preference. In this case, I'm fine with the improper fraction, but if you like to see it as 1 1/7, that's accurate as well. You can go ahead and use that one. All right, now we're going to talk a little bit about dividing fractions. And it's funny because dividing fractions is really just rewriting them so that we can multiply them, because multiplying fractions is easy, isn't it? We're going to start with this little fraction problem. 2/5 divided by 1/3. We're going to do that one. Then we're going to try 3/7 divided by 6. And then we'll try, am I still going to be on the board? 3/11 divided by 5/7. Oh, good. We get all three of those on the board. Okay, now let's look at this first example. When we divide fractions, and hopefully you remember this from younger math as well, that we invert the second one and multiply. We invert the divisor and multiply. So in other words, we rewrite this as 2/5 multiplied by 3/1. Now all the rules for multiplying fractions occur, so 2 times 3 is your numerator, 5 times 1 is your denominator. I don't see anything that can cancel, so I just multiply straight across. 6 in my numerator, 5 in my denominator. Again, that's an improper fraction. Oops. We'll get it on the screen there. That's an improper fraction, 6/5. You may write that as 1 1/5. You may leave it just like that if you wish. Let's look at the second example. This time we're dividing by 6. But if we want to use that same rule of inverting and multiplying, I'm going to have to write 6 as 6/1. Then I'm going to invert or flip this one, and I'm going to get 3/7 times this one flipped, 1/6. Now, at this stage of the game, I look to see if anything can cancel. At first glance, it doesn't appear that anything can, but remember that 6 can be rewritten as 2 times 3. When you see that, then you see that these 3's can cancel. Remember, writing things down into their prime factors can really help you understand this canceling. Then you just multiply straight across. You have a 1 in the numerator, and you have 7 times 2 in the denominator, so we end up with 1/14 as a final answer, 1/14. Now, this is just another way of writing a division problem. They were just saying 3/11 divided by 5/7. So another way to write this is to say 3/11 divided by 5/7. Once we've written it into this fashion, it looks like all the other ones we just did, and we're going to use that invert rule. So we're going to flip the second term here and make it into a multiplication problem. 3/11 times 7/5. From this point, I'm going to look to see if anything cancels. Well, everything is prime. Nothing breaks down and nothing cancels. So we have 3 times 7 in the numerator. We have 11 times 5 in the denominator. We multiply straight across, 21/55. And remember, I told you multiplying and dividing fractions is so much easier than adding and subtracting. You do not have to get a common denominator to do this. You work straight ahead. You do want to look for places to cancel, though, because we want our numbers, we want our fractions in lowest terms. Okay? Now, what happens if we start out with mixed numbers? Let's take a look at this. If I have 1 2/5, and I want to divide that by 2 1/3. Well, we're going to use the skill that we talked about yesterday to rewrite these as improper fractions, and then just use the rules that we know. We write this as an improper fraction by taking the whole number times the denominator. 1 times 5 is 5. 5 plus 2 is 7. In other words, I have 7/5. That can be checked quickly. 5 into 7 goes 1, and I have 2 left over. That's correct. We write this as an improper fraction. 2 times 3 is 6. 6 plus 1 is 7. I get 7/3. Again, that can be checked quickly. 3 goes into 7 2 times with 1/3 left over. Then we use the rule of inverting and multiplying. 7/5 times, invert this second one, 3/7. At this stage, I look to see, can anything cancel? Well, sure it can. The 7's can cancel. And so now what I have, I look at my numerator straight across. I have a 3 in the numerator. I look at my denominator straight across. I have a 5 in the denominator. And 3/5 is my final answer. A lot of math is just rewriting problems into the form that you can